Do you have any applications that you think that are really well suited for air-fuel resonant technology, even though Wireless Power Consortium has become the standard for phones? What else is out there that needs power that air-fuel might be a better technology for? All right, Jim. Good to see you again. Thanks for joining me.
Good to see you, Jacob.
So we've talked a lot about Qi applications, and today what I want to talk about is another standard that's actually been around quite a long time called the Air-Fuel Alliance. It used to be known as A4WP. So what is the Air-Fuel Alliance, and how does it relate to Qi or the Wireless Power Consortium?
Well, it's one of the alternate forms of inductive charging. It seemed like a couple of years ago, Qi won the standards war when there was a big fight between the two to gain dominance. Qi was a little different, where it didn't have much separation between the transmit and receive coils, and in a sense was sort of the low-cost, simpler solution. Resonant took a charge at the lead for a while, and it, from an engineering standpoint, it seemed to be the sexier approach, where you could have larger distances between the coils and greater variations.
Right. I always felt like air-fuel had a higher ceiling.
Yes.
There's more you can do with air-fuel. You can do one large transmitter like the size of an iPad with multiple receivers on it versus Qi, which is one-to-one coupling. But ultimately it seemed like Qi, which was backed by the Wireless Power Consortium, it seemed like that was easier to implement, and it's what Samsung started putting into their phones, I think around 2015. Motorola and Nokia, back when Nokia was making phones, they were putting them in like 2013. So I think, and then when Apple adopted, I think in 2018, it just said Wireless Power Consortium is where it's at, but air-fuel is still around. Do you have any applications that you think that are really well suited for air-fuel resonant technology, even though Wireless Power Consortium has become the standard for phones? What else is out there that needs power that air-fuel might be a better technology for?
Well, there's a lot of devices that have varying sizes of coils, and if you really think of the Qi standard, it's kind of the killer app for smartphones, and that's kind of become the dominant application, and everything else sort of feeds off of that. And you've got a market of 1 billion products, it's going to be successful. The problem is those coils need to be approximately about the same size, so they have to be roughly the size of what a smartphone coil is to really work. With resonant, you can have a fairly wide variation because you don't need to have the tight coupling between the transmitter and the receiver coil. And once you have that, it allows much more or a wide variety of applications.
Yeah. So some applications that come to mind for me that we've seen or are working on, we have IoT applications where you might have a variety of readers or tags, smart tags, that you can put in a drawer, and all of the tags can charge simultaneously. Other areas, I usually think about things that have multiple receivers and one transmitter, because I think that's one of those super hidden benefits of air-fuel. And so hearable technology is a good candidate. We've done things for smart shoes and smart sports technology, where you might want to have multiple sensors that can be worn on the body, but then put in one common place for charging. So one to multiple, or large to small, or bigger distance of separation, those are all real opportunities for air-fuel to shine through, at least relative to Qi.
Yeah, and the other thing is, not only is the wider distance possible, but you can also have more of an angular displacement between the coils and still get reasonable coupling and still get a good charging experience.
Which is important when, phones are flat, but a lot of devices aren't. So you have a ball, like a sports ball, we've actually done that before. So you have other things that are just curved, maybe things that are more ergonomic, like surgical tools or mice, for gaming or PC peripherals. You have all these different things that, they might not be flat, and it's nice to be able to have that angular or theta separation between them.
Yeah.
So we talk a little bit about the applications of air-fuel and what would be appropriate for the technology, but what are some of the challenges of air-fuel technology?
Well, one of the biggest ones, and one of the things I think that WPC and the Qi standard was able to get around quickly, was the communication between the transmitter and the receiver, doing it in the most cost-effective manner. For the air-fuel standard, it uses a Bluetooth, which is a perfectly good link. It just adds an extra communication channel, which adds to the cost. So
it's BLE, is that right?
BLE, yes.
Okay, so Bluetooth Low Energy,
right?
But you need a Bluetooth Low Energy circuit on the transmitter and receiver side. I think oftentimes, under air fuel, you would say a lot of receivers already have Bluetooth low energy in them, like a phone.
Sure.
So it's not going to add cost on that side, and so it's really just adding it on one side. So I think there's an argument that it's not really cost additive, but when you're looking at it from a systemic perspective, whole system perspective, whereas Qi does in-band communication, utilizing the Qi protocol as part of that, it does add a whole nother function of needing BLE for air fuel.
Right. And also when you're going to the kind of the dirt low cost sort of applications that might use wireless power where you're just charging a battery, having an extra communication link then becomes maybe prohibitive.
Yeah, absolutely. And we certainly done some in-band protocol at 6.78 megahertz, which is the air fuel frequency, although not part of the Air Fuel Alliance specification. Can you talk about regulatory issues with doing in-band communication at 6.78 megahertz?
Well, one of the keys with doing in-band communications is the FCC has a separation between using the radio frequencies for communication and then using the radio frequencies for other types of industrial applications. And you can think of your microwave oven as one of those. Sure. There are certain frequencies set aside, the ISM bands, that are really designed to have radio frequencies used as work. So microwave ovens, again, being a good application. There's other medical applications, and it's called the ISM band for industrial, scientific, and medical. And so the FCC allows those bands to have almost unlimited amounts of energy going in the band, but it doesn't allow it for communication. It says communications is something different. You need to keep the noise floor very low for communications because you have receivers far away, so they have very tight regulatory requirements on that.
Well, Jim, thanks for your comments on Air Fuel Alliance and helping provide a little bit of context of where it fits in with the Wireless Power Consortium and other standards.
All right, thank you.